Welcome, distinction students. Let's talk about chemical equations. Good evening, Molenga, Memory, Helen, Precious, Omba, Natalia. Good evening. Okay, so hope you're all doing great. We want to talk about chemical equations. Chem- so, not waste time. So, what we're going to begin with is how do you balance equations? Okay. All right. So, how do you balance the equations? That's what you're going to begin with. How do you balance chemical equations and how do you write word equations? First, how do you write word equations? For you to come up with something like this glucose here, how was it formed? If this is water, how was water formed? So you say this, you first need to know the valences, what you have been talking about. So if hydrogen is reacting with oxygen like this, if these two are reacting, what are they going to form? Of course, water. But how is the equation going to be? You're going to say, what is the valence of hydrogen? How do you check the valency? The number of electrons, simply. The number of electrons which is going to lose or gain. Metals, they lose. Non-metals, they gain. So the number of electrons that they're going to lose to be stable, to be 8 in the outermost shell, that's the valency. Hydrogen has got 1, normal. Hydrogen, we say, okay, Sophia, good morning. Good evening. All right, let's close the section, comment. All right, so hydrogen, it has got 1. Then oxygen, if you follow it properly, we're going to say it has got 8, right? So if you write this 6, so if you write, we're going to say, okay, this is 2 and 6, this is oxygen, right? 2 and 6, so it has got 8 here. Non-metals, we said, how can you tell if this is a metal or this is a non-metal? Let this be the last one. So after drawing the electronic configuration, metals, they have electrons in the outermost shell ranging from 1, 2, and 3. So we're going to do this. How do you know if it is a metal or non-metal? So we're going to say metals. So make sure rotate your phone and the non-metals. So these they gain so that they can be 8. These they lose electrons in the outermost shell so that they can be 8 stable. So now how can you know that this is a metal? Metals, they have electrons in the outermost shell ranging from 1, 2, and 3. Then if it is a non-metal, it will have electrons in the outermost shell starting from 4, 5, 6, 7. Okay, so sometimes they'll just say element X. It has got the electronic configuration of 2, 8, 3 without even you knowing. Now, is X a metal or a non-metal? X is a metal. Why? Metals, they'll have 3 electrons in the outermost shell. Metals will have 2 electrons in the outermost shell. And metals, they'll have 1 electron in the outermost shell. What if we have element Y, which has got 2, 8, 8, 1? Is this element Y a metal or a non-metal? We'll say element Y is a metal. Why? It has got a single electron in the outermost shell. Number 3, if you see any element, it has been written. Okay, so if you see an element which is like this, okay, let's say element X, it has got 2, 8, 7. Is this a metal or a non-metal? You find that this element, it is a non-metal. Why? Metals, they only have 1 electron in the outermost shell, 2 electrons in the outermost shell, or 3. But non-metals, they'll have 4, 5, 6, 7 in the outermost shell. So this is a non-metal. Now, we said that metals, they lose 1 electron, they lose 2 electron or 3 electron so that they can be stable, having 8. While non-metals, we said they gain electrons so that they can become 8 or so. So now what will happen to this? Now, this is the stage, the order which we want to follow. Okay. So say after saying they lose, they gain, what is the valency? A valency is the number of electrons lost, gained, or shared by an element. So if hydrogen reacts with oxygen like this, what will be the chemical equation? How do you write chemical equation? By understanding the valences. Hydrogen has got 1, so the electronic configuration is just 1. Oxygen is 8, so it is 2, 6. I see that. So hydrogen, it loses 1 electron. So meaning you're going to say hydrogen, you say hydrogen has got to positive 1. Then we have oxygen this side. Oxygen, is it a metal or a non-metal? Non-metal, because it has got 6 electrons in the outermost shell. How many electrons does it need for it to be stable, to be 8? It needs 2 electrons. So the charge here will be negative 2. Why? Meaning it needs 2 electrons. So how do you form chemical equations? You swap the valences. For you to form the chemical equations, you need to understand the valences. When you understand the valences, you just swap the chemical equation. So I've said hydrogen has got 1 positive. Oxygen, we said it needs 2 electrons to be stable. So if you want to write the chemical equation, you switch them like this. So it will be hydrogen with a 2 from oxygen, and the oxygen will have 1. Therefore, you have formed what we call what? Water. This is how water is formed. All right, so now if we have another one such as magnesium, magnesium is reacting with chlorine. So magnesium is 12, chlorine is 17. The electronic configuration, the first shell is 2, the second shell must have 8, so this is 10. For it to be 12, there's 2. Is it a metal or a non-metal? This is a metal. It has 2 electrons in the outermost shell. We go to chlorine. You draw the electronic configuration, 2, 8, 7. So this is 17. Is it a metal or a non-metal? This is a non-metal. It has 7 electrons in the outermost shell. So this non-metal, it needs how many electrons for it to be 8 to be stable? To be stable, the octet rule is supposed to have 8 electrons in the outermost shell. It needs a single electron. So we'll just say single electron in form of negative. Because non-metals, when they gain, they become negative. Metals, when they lose, they become positive. That was explained in the video that I sent. So magnesium is a metal. It's supposed to lose how many electrons to be stable? It loses 2. So it will be 2 positive. As it loses, it becomes positive. So we'll say magnesium with a 2 plus, chlorine with a negative, its valency. So how will be the equation here? You cross the valences, where the 2 comes to chlorine, the 1 goes to magnesium. Therefore, it will be magnesium with the 1, you ignore it, and chlorine with a 2, magnesium chloride. Okay, this is how you form chemical equations. And the last one before we go to balancing chemical equations now, I'll give you this other last one. Let me say aluminium. Aluminium is 13, is reacting with oxygen, which is 8. So electronic configuration is 2, 6. This is 2, 80, 3. Okay, so we'll say aluminium. Is it a metal or a non-metal? It's a metal. It has got 3 electrons in the outermost shell. So it's supposed to lose how many electrons? The same electrons in the outermost shell, they will be lost. So magnesium, aluminium, it will lose 3 plus. So this 3 plus on top, it tells you the number of electrons it is losing. Then we have oxygen. It is gaining how many to be 8? 2, right? So it will be 2 negative. So we have a 2 for oxygen and 2 for aluminium. So it will be aluminium with a 3 plus, oxygen with a 2 negative. How do you write the weight equation? You crisscross the valences, where aluminium, it will get the valence of oxygen 2, and oxygen will get the valence of aluminium 3. This is called the weight equation, or sorry, the formula. Okay, so after talking about these now, writing with equations, now you know, we'll go to balancing chemical equations. How do you write chemical equations? So an equation, it is derived because of its word equal, from equal. So if A plus B reacts, they give you C plus D. These that we are reacting are known as reactants. Then these that were formed, they are called the products. Number 2, when balancing chemical equations, you're going to have a number like this. You're going to have something like this. So, okay, this is hydrogen. There's a number on top, like here on the first, and there's a number down. These numbers are different. This number here, it is showing an atom, okay, atomic number. So this is the atomic number, or the number of atoms present. Okay, number of atoms present. Then this number, it is showing the number of mole of that thing, the molar number or the coefficient. So when balancing, you do not touch this number which is down. You should never change anything down here. The only part where you change or balance, it is the mole or the number in front of the element. When balancing, you don't touch the number which is down here, meaning you are changing the name of the element. You only change the number which is here. Okay, if there's nothing, that's how you're supposed to change it. So you make sure you check. So if I give you nitrogen like this 4, I ask you how many atoms are present here and how many elements are present here. So the elements, how many elements do we have? We have the element nitrogen and hydrogen. So we have 2 elements of nitrogen and hydrogen. Then how many atoms do we have? We have 4 atoms of hydrogen plus 1 atom of nitrogen. Therefore, together the total number of atoms present here is 5 atoms present. 5 atoms of all elements, meaning 4 atoms. Okay, you say 4 atoms of hydrogen, 1 atom of nitrogen. But how many elements do we have? 2. Element hydrogen, element nitrogen. Okay, so let us balance the equations now. I even open the chart. Balancing now. All right, so chemical equation, like we have said, you have got the reactants, So these are called reactants. There's a huge here, the equation, and these are the products. So imagine glucose reacting with water. Carbon dioxide reacting with water. It will produce glucose plus oxygen. So how do you balance this? It's also part of what you're going to balance. When balancing, you're going to use this method of saying trying and error. Try and error. So we have C3H8 plus oxygen. I'll write it here. Okay, we have C3H8. It's reacting with oxygen. So when this reacts, it will give you the equation, which is water plus carbon dioxide. So it will give you water like this plus carbon dioxide products, meaning you have balanced the equation. What do? You list them, you separate them. How many elements do I have in the to the product side? I have got hydrogen, I have got oxygen, and I have got carbon. What about this side? Okay, I also have hydrogen to the reactants, 2 atoms of hydrogen. How many atoms of oxygen do we have to the products? Even a plus, but as long as it's to the product. We have 2 here plus 1. Okay, therefore we have, oh no, we have 3. Okay, so we have 3, so meaning we have 1 carbon. We go to the reactants. Reactants, hydrogen, how many atoms do we have? So we have got 8. Wow. Oxygen, how many atoms do we have? We have got 2. Then carbon, how many do we have? We have got 3. So meaning to the reactants, we have more atoms than to the product. So where are we supposed to put some atoms to balance them to the product? So our focus will be to the products. That's where the focus is going to be. So we're saying that the focus is going to be to the products. Okay. So if this side hydrogen is 8 and this side hydrogen is 2, how are we going to balance this? Okay. So we'll start. What if I put 4 in front? You always put the number in front, not down, in front of the element or compound you're solving. And if you put a number in front, that number is for everything. E.g., if I say this is water, then I put a 2. This 2 is for hydrogen, meaning hydrogen is going to be 4. You say 2 times 2. And this 2 is also for oxygen, meaning oxygen is going to be 2. The 2 is for hydrogen. The 2 is also for oxygen because it is in front of a number. Now, if you have something like this, hydroxide, open brackets, close, and you have a 2 down. This 2 is for everything inside the brackets, meaning hydrogen here has 2 and oxygen has got 2. So if you put any number in front, just know it will affect this and it will affect this next element. Okay. So any number that you're going to put in front, just know it is going to affect everything, all the elements that you have. Okay. So let us continue balancing the equation. How are we going to make the products to be like the reactant? So now let us check. We are starting polyhydrogen. How do we make hydrogen to become 8? If we put 4 here, meaning 4 times 2, hydrogen will be temporarily 8. Temporary 8, we don't know yet. Then oxygen is going to be what? Oxygen is going to be, don't forget, this 4 affects everything here. So 4 is for hydrogen, 4 is also for oxygen. So meaning oxygen we have 4 plus another 2 atoms for oxygen. Oxygen tankana 6. We are not yet sure. Okay. Meaning what else is remaining? Carbon. So if we put a 4, hydrogen is going to be 8 8 like this. Oxygen is going to be 6. But this side, oxygen is not balanced. How do we make it 6? If we put a 3 to where oxygen is, oxygen will be 6 like this. But carbon this side, you have got 3. Okay, so carbon this side, you have got 3. So how do we make carbon also to be 3? We're going to do this. If we put a 2 here, carbon is still not yet balanced, meaning we're not going to put a 2, we'll put a 3. So if we put a 3, carbon, yes, will be 3, but the 3 is also affecting oxygen. So therefore, oxygen has got now 3 times 2, it is 6. 6 plus this 4 for oxygen, so oxygen is now 10. Oxygen is 10, meaning this side will just put a 5 like this. So let us balance it from here. Okay, so this is the equation. We are saying if we put a 3 here, it's a try and error question. So the technique is known as try and error. So we have water here to be okay. So meaning carbon is now 3. Cancel. Okay, so meaning carbon is now 3. Now this 3 affects carbon and oxygen. So 3 times 2, oxygen has got 6. So meaning oxygen is 6. Don't forget there was a 4 here. So meaning this 4 is for hydrogen, is also for oxygen. 10. Okay. Then hydrogen, 4 times 2 hydrogen is 8. And this side 8, meaning the equation is balanced. How is the equation balanced? By putting a 4 here. So on this was just a sample. Here we put a 5. Here we put a 4. Okay, here we put a 3, meaning it is balanced. This side, let us check. Hydrogen this side tunazingatia 4 times 2 hydrogen, we have got 8. Oxygen 4 plus this 3 times 2, we have got 6. So 4 plus 6, oxygen, we have got 10. What about this side? 5 times 2 oxygen, we have got 10. Carbon, we have got 3. Carbon, we have got 3. Meaning the equation is what? Balanced. This is known as try and error. So we have this other equation that we need to balance. Oxygen 1. How do we balance it? By simply adding 2's. By simply adding the 2's. So here we're going to say we'll put a 2 here. So if we put a 2 in front, the 2 it will be for carbon, nitrogen, the 2 also be for oxygen, meaning it is balanced. Next, we have mercury oxide here to give us mercury and oxygen. How many atoms of mercury do we have, Uku? 1. Oxygen, 1. Atom of mercury here, 1. Oxygen, 2. So how do we balance this? We say, for us to balance this one, we're going to say, because oxygen we have 2, we'll just put a 2 in front here, meaning mercury will be 2. Here 2, mercury 2, 2. Oxygen 2, oxygen 2. This is balanced also. Ion reacting with oxygen to form hematite 3 in front of hematite. So let's try putting a 3. So if we put a 3, meaning ion is going to be 6. Oxygen is going to be 9. Okay, so meaning you try and error now. You say, okay, Yakuri set a fuck up. We put a 2. Simple. If I put a 2, ion will be 4. Then oxygen will be 6. So here I'll put 3. Oxygen, it will be 3 times 2, 6. Here I'll just put a 4. Meaning ion 4. Here Okay, so if it is clear, you just show me there, then I'll know that this is clear. So balancing, this is all about balancing. I was telling you balancing is very simple. The next time we'll talk about net ionic equations. That's, I think, Saturday. So this is how you balance. You can even balance this. We have and calcium and bromide. So bromide we have 2, calcium I've got 1, and this side bromine 2, calcium 1. So this equation is already balanced because to the reactants we have 2 atoms of bromine, and to the products we have 2 atoms of bromine. Calcium, to the reactants we have got 1 atom, and to the products we have got 1 atom, meaning it is what? Balanced. This one we have got P, phosphorus, it is 4, and this side it is 4, it is balanced. Phosphorus is balanced. Oxygen, this side we have got 10, this side you have 2. So to make it 10, what we do? We just put a 5, meaning it is balanced also. Are you seeing that? Then we have this side here. Okay, so butane, we have carbon 4. Carbon, this side we have got 1, so we'll put a 2 in front. Okay, so this 2, it will do nothing, so we'll put a 4. We'll put a 4 in front. So we're going to solve. What if we put a 4? Meaning carbon is 4, this side carbon 4. This 4 is for oxygen also, so oxygen is now 8. Okay, 8, we have another one here, 8, 9. So let's make it 10. We'll put a 2 in front here. So oxygen has got 4 times 2, 8. 8 plus this 2, oxygen is 10. To make it 10, this side we put a 5. Are you seeing that? Try and error. But hydrogen, this side it will be 4. This side hydrogen will be 8, meaning it is wrong. What do? You change the oxygen, the number here, you make it 4, like this. So if you make it 4, meaning it will be 4 times 2, hydrogen will be 8. Oxygen will be 4. Affected. So oxygen will be 4. 4 plus this, another one here, meaning oxygen is going to be 8, 9, 10, 11, 12. So oxygen will be 12. So to make this other oxygen to be 12, what do? We just put a 6 here. 6 times 2, 12, meaning it is balanced. Just like that. So this is how you balance chemical equations, as simple as that. Number 1, know how to form valences, what valences are. How do you form chemical equations? You do try and error. So this is called try and error. You write them, the elements that you have. We have carbon, which is 1. We have hydrogen, we have 4. And we have oxygen, so oxygen we have 4 also. This side to the products we have carbon 1. We have hydrogen also, it's 4. And we have oxygen, it is 4. So meaning the atoms are balanced. That's why it is like this. This is how you leave the equation. You do try and error. So don't forget how you know metals. Metals, they have got in the outermost shell 1 electron, or 2 electrons, or 3 electrons. Just know it is a metal. These electrons in the outermost shell, they tell you the valency. If it has got 1, meaning the number on top, it will be a positive 1. If it has got 2 electrons in the outermost shell, meaning it is a 2 plus. Okay, if it has got 3, meaning it is a 3 plus. The valence is the number of electrons lost. So if it was losing 1, that's the valency. 2, that's the valency. 3, that's the valence. To non-metals, the valence is the number of electrons gained. So if it is gaining 2 to be 8, it is 2 negative. This is showing you it needs 2. If you see a 3 here, or if you see a 4 negative, meaning it is gaining 4. Okay, so this is what you need to understand about chemical equations. I believe this was clear and straightforward. So if you have any questions, you can ask before we close the chat. Otherwise, this is all about balancing chemical equations. The next time we have class, we'll talk about net ionic equations, where if net ionic equations, where if we have something like hydrogen, like this reacting with water, this to give you water. Okay, what would be the ionic equations just like that? Okay, if sodium chloride is reacting with something, it is in aqueous form. Those where we say aqueous, sodium, aqueous, positive, aqueous. Okay, chlorine, negative, aqueous, cancelling them. Those are net ionic equations. So those are the things which we're supposed to do next. So if there are no any questions, this was the class. It is done. If you have any complaint, you have something to say, comment there or see you in the group. Otherwise, bye bye.